Hello student, I am Professor Devashish Bose, Head, Department of Criminology and Forensic Science, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar, Madhya Pradesh. Today I am going to present a lecture of BSc 5th semester on the unit General Idea and Examination of Acids and Alkali in Forensic Toxicology, which has been jointly prepared by myself and Ms. Priyanka Pahade, a PhD research scholar, UGC GRF at Department of Criminology and Forensic Science, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar. Let's start our discussion while taking a look at what we are going to learn today. Today's lecture is been divided into 7 modules. Module 1, Introduction and Definition of Acids and Alkalis. Module 2, Classification of Acids and Alkalis. Module 3, Preliminary Examination of Acids and Alkali. Module 4, Confirmatory Examination of Acids and Alkali. Module 5, Forensic Importance of this poison. Module 6, Case Study, and finally Module 7 will be our conclusion. Dear student, today we are going to learn about acid and alkali. Most of you have learned about them in your school days, but today we will learn them as per forensic point of view. In forensic science, those acids and alkali includes that erode and destroy living tissues with which it comes in contact. Acids and bases have been known for a long time. When Robert Boyle characterized them in 1680, he noted that acids dissolve many substances, change the color of certain natural dyes. For example, they change litmus from blue to red and lose these characteristic properties after coming into contact with alkalis. Acids and bases are common solutions that exist everywhere. Almost every liquid that we encountered in our daily life consists of acid and basic property, with the exception of water. Acids are substances that has a corrode and destructive effect on the human body. It is almost exclusively locally acting and has very few systemic effects, with the exception of generalized shock. We will employ 3 definitions of acid and bases during the course. 2 of these will be used more often, while the third one will only be used briefly. These are not the only definition of acids and bases. There are a wide variety of definitions to the point that we can classify nearly every chemical as an acid or base. We will not attain that level of purity. Our effort will be to keep it simple. In fact, we will progress from the simple definition to the more complicated one. The 3 definitions that will be used are Arrhenius definition. According to Arrhenius, an acid is a substance that, when dissolved in water, ionizes to form hydrogen ion. A base is a substance that, when dissolved in water, ionizes to form hydroxide ion. Example for acids: when hydrogen chloride HCl is added to water, it ionizes to form H plus ion and a Cl minus ion. The equation which describes this process is HCl plus H2O gives H plus and Cl minus ions. HCl is an acid because when it dissolved in water, it ionizes, producing H plus ion in solution. Any other compound which similarly produces H plus ion when added to water is also an Arrhenius acid. Example for alkali: when sodium hydroxide NaOH is added to water, it ionizes to form Na plus and OH minus ion. That is, NaOH plus H2O will give Na plus plus OH minus ion. Bronsted-Lowry definition. A Danish chemist, Johannes Bronsted, and a British chemist, Thomas Lowry, noted that it is possible to look at Arrhenius reaction in a slightly different light as proton transfer reaction. They define acid as a substance that donates a proton and a base as a substance that accepts a proton. Lewis' theory of acid and bases states that acids are electron pair acceptor while bases are electron pair donor. Dear student, as you know, there are many acids and alkali, but in forensic science, we will only learn about corrosive acid and alkali. The term corrosive originally referred only to those acids which corrode metal. Similarly, the term caustic was used exclusively for biologically toxic bases like caustic soda. On the other hand, alkalis produce a liquefaction necrosis of tissue. Classification of acid and alkalis. Acid and alkalis could be classified as strong acids, strong alkalis. Acid. An acid is a substance that tastes sour, reacts with metal and carbonates, turn blue litmus paper red and has a pH less than 7. Inorganic acids. A mineral acid or inorganic acid is an acid derived from one or more inorganic compounds. It does not contain a carbon atom. All mineral acids release hydrogen ion when dissolved in water. Acids are potent desiccants with the ability to produce a coagulation necrosis and ischial formation of injured tissue. Some of the inorganic acids are hydrochloric acid, sulfuric acid, nitric acid, etc. Hydrochloric acid is also called muriatic acid or spirit of salts. In pure form, it is a colorless gaseous liquid and has an irritating smell. It does not stain mucous membrane. In large dilution, this acid is harmless and helps in digestion process, but in strong dose, it corrodes mucous membrane. Signs and symptoms. In air passage, it causes corrosion. If concentration increases, it may corrode mucous membrane. It is quite less damaging as compared to sulfuric or nitric acid. It does not stain mucous membrane. In large dilution, this acid is harmless and helps in digestion, but in strong, it does corrode mucous membrane. Sulfuric acid. It is also called battery acid or oil of vitriol. It is the most powerful acid. It is colorless, heavy and hygroscopic. It mixes with water and evolves heat when mixed. The teeth become chalky white in color. Vitriolage, that is acid throwing. It is commonly seen when a person wants to disfigure the face of another person. Signs and symptoms. It may produce burning pain in mouth, throat and stomach. Tongue is swollen and covered with white coating, which later becomes dark and then brown. Teeth becomes chalky white in color. Corrosion seen in chin, angle of mouth and hand. Stomach appears like blotting paper and later it may look like spongy black mass. Nitric acid. It is a clear, colorless liquid, gives fume when exposed to air. It is a very powerful oxidizing agent and can dissolve all metals except gold and platinum. Commercial preparation may be of yellow color due to the presence of lower oxides of nitrogen. Signs and symptoms. It has a property to convert protein into xanthoproteic acid. When this inorganic acid comes in contact with the lips, tongues and mucous membrane of the mouth are first softened and white in color and later turned into intense yellow color. The teeth also become yellow. The skin and clothes become yellow. Fumes of nitric acid can cause irritation in eyes, leading to damage. Fumes may also cause dyspnea and constriction in throat when inhaled. Now we come to organic acids. An organic acid is an organic compound with acidic property. The most common organic acids are carboxylic acid, whose acidity is associated with the carboxylic group. Carbolic acid, phenol or carbolic acid is a corrosive aromatic hydrocarbon that is widely used as a disinfectant and in the formulation of industrial solvent. It is obtained from coal tar by fractional distillation. It is colorless, prismatic crystalline substances resembling magnesium and zinc sulfide. It is bitter in taste and soluble in water. It vaporizes on heating and sublimates on cooling of the vapor. Household phenol contains 5% phenol in water. Although known as an acid, it does not turn blue litmus paper red and has no acidic reaction. Signs and symptoms. It causes intense burning in mouth and throat. Membrane of the lips and mouth becomes white. If absorbed in blood, it causes giddiness, insensibility, after that deep coma. The face becomes pale, skin cold and clammy. The blood pressure decreases, smell of carbolic acid in breath, convulsion. Urine is greenish color. When exposed to air, it becomes dark. This is called carborera. Salicylic acid. This occurs as white, odorless, crystalline powder having acidic taste. It does not dissolve in water easily. The acetyl salicylic acid is very extensively used as an analgesic and is a component of various medicines used in the management of fever, skeletal pain, control of inflammation, arthritis, etc. Its important preparation are sodium salicylate, methyl salicylate or oil of wintergreen, which is actually a liniment containing 25 gram methyl salicylate per 30 ml, and acetyl salicylic acid or commonly known as aspirin. Salicin and methyl salicylate are naturally occurring forms of salicylates found in the leaves and bark of a number of plants, especially the willow tree. Alkalis. Ammonia. The gas of ammonia, when dissolved in water, forms a strong ammonia solution, commonly also known as spirit of hartshorn. It is a very strong alkali with a pungent odor. It is commonly used in refrigeration and fertilizer industry. Potassium hydroxide. It is hard, deliquescent and is available as pencils or cake. It is soapy to touch, acrid in taste and is very soluble in water. It is a highly strong alkali. Sodium hydroxide. It is white, solid mass and resembles potassium hydroxide. It is highly soluble in water and is a very strong alkali. Mixture of sodium and potassium hydroxide is commonly referred to as lye. It is used for drain or oven cleaning. Sodium carbonate. It is also known as washing soda or simply as soda. The chemical formula is Na2CO3. It is transparent, monosystemeric crystal and becomes white when exposed to air. It is quite soluble in water. It is a strong alkali, commonly used for washing and cleaning purpose. Signs and symptoms for alkali. The alkalis produce usual symptoms as acid except the following one. The taste of alkalis is acrid or soapy. The vomited matter is very alkaline and does not effervescence as in acids when comes in contact with earth. Purging is quite common in alkalis while it is rare in acids. Severe pain with bloody diarrhea may be seen. The ammonical vapors are very irritating to respiratory system. They produce congestion and watering of eyes too. Pulmonary edema may be seen. Preliminary test, commonly referred to as the spot test. Generally, a simple color test which, if they are positive, indicates the possible presence of a particular substance in sample matrix. Preliminary test for sulfuric acid. Test with barium chloride. A few drops of barium chloride solution is added to 2 ml of extract. A white precipitate is formed, which is insoluble in hydrochloric acid and nitric acid. 25 ml of extract is taken in a test tube fitted with a bent tube and concentrated by boiling. A small piece of copper turning is added and boiled again. The gas liberated, if any, is passed through a weak solution of potassium permanganate, 0.1% weight by volume. The pink color of the solution is gradually discharged or fades away. Preliminary test for hydrochloric acid. Gunzburg test. A few drops of Gunzburg reagent is taken in a porcelain dish, evaporated to dryness over a small flame and cooled. A glass rod together with the material to be tested is added to the dried reagent. It is warmed gently. A purplish red color developed in the presence of free hydrochloric acid. Silver nitrate test. A few drops of silver nitrate solution is added to 2 ml of the sample. A curdy white precipitate is obtained which, is soluble in ammonia or potassium cyanide and insoluble in strong nitric acid even on boiling. HCN also gives a white precipitate under the same condition, but it is soluble in nitric acid on heating. Preliminary test for salicylic acid. To 1 ml of concentrated extract of biological material or urine, 3 drops of ferric chloride solution is added. A violet color indicates the presence of salicylic acid. McNeil's test. To the residue of extract of biological materials, a few drops of acetone and 1–2 ml of water are added. 2 drops of 0.5% copper sulfate solution in 10% acetic acid is added, followed by a pinch of solid sodium nitrate. It is shaken and heated gradually to boiling and maintained in boiling condition for a few minutes. A red color is formed if salicylates and salicylic acid are present. Preliminary test for carbolic acid. Test with lime water. To 2 ml extract, a few drops of lime water is added. A white precipitate insoluble in acetic acid and ammonia solution, but soluble in dilute HCl or HNO3 appears. Test with calcium chloride. 2 ml of extract is neutralized with ammonium solution. A few drops of calcium chloride solution is added. A white precipitate is formed. Preliminary test for potassium. Test with perchloric acid. The test solution is neutralized with HCl. A few drops of aqueous solution of perchloric acid is added to 2 ml of neutral solution. A white crystalline precipitate appears. Cobalt nitrate test. The test solution is acidified with acetic acid. A few drops of freshly prepared solution of sodium cobalt nitrate is added. A yellow crystalline precipitate of potassium cobalt nitrate is formed. Preliminary test for ammonia with Nessler's reagent. A yellow or brown coloration appears. With chloroplatinic acid, 2 ml of test solution is neutralized with HCl and a few drops of chloroplatinic acid is added. A yellow crystalline precipitate is formed which is soluble in 80% alcohol. Dear student, as you all know, confirmatory analysis are sophisticated analytical methods selected to provide answers that are essentially incontrovertible. They must be sensitive and specific. If they do not meet the specificity, confirmatory analysis are the last analytical step. They must therefore be extremely reliable. Confirmatory examination of sulfuric acid. Sulfuric acid and soluble sulfates in biological materials are estimated by gravimetric method. Other methods is titration method, which is used to quantitatively determine sulfuric acid in biological matrices. Confirmatory examination of hydrochloric acid. Qualitative determination of hydrochloric acid and chlorides by weighing method. pH determination using pH meter. Confirmatory examination of oxalic acid. Quantitative determination of oxalic acid and oxalates by weighing method. Confirmatory examination for potassium. By gravimetry, potassium is precipitated as potassium chloroplatinate. The weight of chloroplatinate is multiplied by the factor of 0.1155 to give the amount of COOH present in the weight amount of biological material. Another instrumental technique for this is ion chromatograph, by which accurate amount of acids or bases can be estimated. Sulfuric acid. Vitriolage or acid throwing is common in recent time to disfigure the face of other persons. Common victims are women. Accidental drinking is usually not possible, but this can occur in children. It is also used as suicidal poison by some psychotic person, but this kind of activity is very rare. Sometimes disposal of the dead body may be affected by throwing the dead body into the acid with an attempt to dissolve the body of the victim, as was practiced by John George Haig, the so-called acid bath murderer. However, the attempt was not completely successful and the skeletal remains is available. Hydrochloric acid. It is used in industries for chlorine production. Acute exposure to the vapors in the industries may lead to death due to respiratory distress. In fatal case of poisoning by these acids, no trace of the poison may be discovered in the viscera, especially when the victim has survived for a couple of days or more. Salt of these acids being common constituent of food and medicine. It is important to ascertain whether any of these acids is present in the free condition. The quantity of free acid present is especially important in HCl poisoning, as this acid is contained uncombined with bases in the gastric juices to the extent of about 0.2% or more. Used for dissolving metals in industry, so accidental poisoning may occur. Accidental and suicidal poisoning have been reported in people working in the industry. Homicidal poisoning is rare. Carbolic acid. Because its large number of derivatives which are used in hospital practice as antiseptic, disinfectant, caustics, germicides and preservative. Phenol is a common suicidal poison due to its easy accessibility and availability. Accidental poisoning may occur when children take it, as it is common household disinfectant. Chronic intoxication may occur from inhalation of vapors from industrial sources. Carbolic acid may normally occur in the urine in traces in the form of phenol, sulfonate or potassium derivative from the digestion of aluminous substance or of their putrefaction. Salicylic acid. Accidental poisoning is common when it is taken in large dose. Aspirin is a very commonly used medicine. Children may consume it accidentally. Suicidal poisoning is very less and rare but reported. Homicidal poisoning is very rare, as very large dose is required to kill a person. For alkalis, poisoning by alkali is much less as compared to acids. Most of the poisoning is accidental or suicidal. Homicidal poisoning is very rare. Caustic soda may be locally applied to neck of ox or buffalo to make it unfit for agriculture purpose, so that it would not be able to bear yoke of a plough due to the local corrosive effect of caustic soda. Accidental poisoning may occur if mistaken with any medicine. The most common poisoning caused by alkali is generally caused by ammonia. This is a case reported by Vijayanath V. Raju. During medical examination, they are reported a case of an 18-year-old unmarried male youth, goldsmith by occupation, reported to psychiatry OPD of a general hospital with complaints of severe suicidal idea and suicidal gestures through hanging, sadness, loss of interest in work and daily activity, easily fatigable, lack of concentration, sleeplessness and lack of appetite for 3 weeks duration. Patient was on empty stomach. Considering his strong suicidal ideas, ECT was planned. While making arrangements for administration of ECT, patient was made to wait in the reception along with attendants. After a lapse of about half an hour, he was taken on the ECT table. There the doctor smelled pungent odor. When the observation was continued, patient became restless and was clutching his upper abdomen. On enquiry, he complained of burning in chest and severe pain in abdomen in the gastric region. A tentative diagnosis of acid poisoning was done. As the patient developed difficulty in breathing and became semi-conscious, he was put on assisted breathing through ventilator. The patient's condition gradually deteriorated and he died after 2 hours. An autopsy was performed 6 hours after the death. Autopsy revealed extensive demarcated cutaneous burns on the inner aspect of the lips. The stomach was perforated, discolored and was disfigured. The liver and spleen were fixed to thoracic cage, hardened on the outer surface and was covered with approximately 2 cm of the firm grey tissue on the surface. Viscera was collected, sealed and sent to FSL. Report from forensic laboratory. The report says This mixtures resulted from dissolution of the muscles lying the inner aspect of the body cavity and presence of sulfuric acid, and the pH is of 2.5 in the pleural fluid. The most noteworthy finding were a chemical test resulted which indicates the presence of sulfuric acid and pH of 2.5 in the pleural fluid. It shows that the person drank sulfuric acid due to suicidal tendency before almost 5 hours of his death. Dear student, at the end, finally we are going to conclude this impressive lecture which was totally based on acid and alkalis. We saw that how we can classify acid and alkalis and what are their properties, which type of instrument and preliminary examinations is necessary for them. With all this information, here we come to the end of today's lecture. Do keep in mind what we discussed today. It's time for you all to do some self-study. This is Professor Devashish Bose signing off. If you want to learn more and enhance your knowledge, you may log on to our website for MCQs, quizzes, LORs, etc. Do visit at www.cec.nic.in. Till then, goodbye and thank you.